derivative was performed, and then we decided the values for our resistances. So we have a total of 3 trials, where in the first trial, the resistances were 40 and 45. For the second trial is 50 and 55, and lastly for third trial is 60 and 65. For the voltage of the battery, it was set to 60 volts, which remained constant throughout the whole experiment. As we go along with the experiment, an assigned member was given a task to record all the values for each current at the voltmeter. After all of that, the total for each resistances will then be computed using the given formula, and then the data will be placed in the table to be shown afterwards.
Because when the sun shines, we shine together. Told you I'll be here forever. Said I'll always be your friend. Took an oath that I'm stick it out till the end. Now that it's raining more than...
Resistors are said to be connected in parallel. The voltage drops across all resistors are the same and equal to the voltage source. The total resistance in a parallel circuit is always less than any other resistances. Ohm's law states that the current which flows through a conductor is directly proportional to the voltage and inversely proportional to the resistance. This means that the lower the resistance, the higher the current, and the higher the resistance, the lower the current. But the voltage stays the same or isn't constant. When two or more resistors are connected so that both of their terminals are respectively connected to each terminal of the other resistor or resistors, they are said to be connected together in parallel. The voltage across each resistor within a parallel combination is exactly the same, but the currents flowing through them are not the same, as this is determined by their resistance value and Ohm's law. Then, parallel circuits are current dividers.
In a parallel circuit, the total resistance equals to the sum of the inverses of each individual resistance. In a circuit, resistors can be connected in series or parallel. The total resistance of a group of resistors is determined by their individual values as well as the way they are connected. When each resistor is connected directly to the voltage source by connecting wires with negligible resistance, the resistors are in parallel. As a result, the maximum voltage of the source is added to each resistor.
The current drawn in each resistor is the same as if it were the only resistor connected to the voltage source. This is true of a home or apartment circuitry. Each appliance connected outlet, the resistor, can work on its own, and the current does not have to pass through each appliance in order.
For our analysis, we have noticed that as we increase the values of each resistor by trial, the resulting total value of the resistance decreases, which displays an inverse relationship. The relationship between the resistance and the current is also inverse, which follows Ohm's law, which states that as the resistance increases, the current decreases, and vice versa. The values for all the voltage is at constant 60 volts, which meant that for the entire circuit, the same value of 60 volts run through.
Therefore, we conclude that the Ohm's law can still be observed in a parallel circuit based on the inverse relationship between the resistance and the current. The voltage remains the same across each resistor, and the total resistance decreases as the resistance value increases due to the fact that more components are added in the circuit, which results to more paths for the current to pass through.
I got your picture, I'm coming with you, dear Maria, count me in. There's a story at the bottom of this bottle, and I'm the pen.